Now, we're going to take up one more problem on the principle of superposition. The problem reads as the problem number 23. Determine the stress in different segments of a circular bar shown in figure. So this is the bar which is shown in figure. What are the different stresses in each segment? So you have two segments here, which is of having diameter 20 and having length as 100, and here the diameter is 30, having the length 200. Also compute the elongation, total elongation of the bar if E equals 200 GPa. So here there are two cross sections of the bar, and having the loads which is applied at 300 kilonewton, and here it is 200, and here is it's plus P. So here, when you are considering this, so the convention what we follow on a section, if you are considering, there are two things. When you are considering here, from a point, if you are moving towards the left side, so which is going to be tensile as the positive value, and on the right hand side, from a point, if you are moving towards the right side, it is going to be a tensile load. So obviously it should be positive. So then here, the other cross section, if you are moving from a point, if you are moving towards the right side, then towards the left side, then it becomes compressive on the right hand side. So then it becomes negative. So according to this problem, if you are considering here, we have 300 kilonewton on this side, 200 kilonewton on this side. So obviously this P also should be equal to 200 kilonewton. So obviously when you are considering that, so you can see here 300 kilonewton on the left hand side. So obviously you should have 300 here. So 200 onto the right hand side, that is 200 kilonewton, which is, since it is a tensile load, which is going to be positive. And again 200 kilonewton towards the right side, so obviously it should be positive. So 200 plus 200, 200 plus 100 will going to become plus 300. Since it is plus, so obviously it should be towards the right side, which is positive. So this is on the right hand side. The right end having to the right side will going to be a tensile load. So obviously it will be positive, 300 kilonewton. Now similarly, when you are considering for the second section, when you are considering, again you have the load which is acting towards the left side, which is tensile, which is positive. On the left hand or the left hand side, if it is acting towards the right side, then it becomes the compressive force, which will be negative. So what are the different segments you have in the second section? 300 towards the left side and 200 towards the right side. So 300 towards the left side is positive, so 300 minus, this is to the right side, so you will going to get is minus 200, so it will be plus 100. So that means, so here plus 100. So similarly, if you are taking to the right side, which is positive on the right hand side, which is 100 kilonewton towards the right side, so obviously it should be tensile. And since it is plus here, it is obviously to the left side, which is equal to 100, so 100 kilonewton. So in both the cases, in both the segments, you will going to have the load will be tensile load. So here this diameter is having 20 and having the length as 100. So this diameter is 30, having the length as 200. So since we have analyzed this free body diagram of both the segments, now we will try to solve the problem. For equilibrium of the bar, so what is the consideration? Load acting towards the right side must be equal to the load acting towards the left side. So what is the load which is acting towards the left side? 200 plus P, because both are acting towards the left side. When you are considering here, if you are considering 300 towards the left side and 200 towards the left side and P towards the right side, so both are acting towards the right side and 300 is acting towards the left side. So 200 plus P will be equal to 300. Therefore, they obviously will going to get that value as P as 100. So that is the reason why that P we are considering as 100 kilonewton here. So once you get this, now we will go into the free body diagram of deferments are shown in the above figure. Yes, we have analyzed that. Now what is the stress in the segment 1? Sigma 1 will be equal to P1 by A1, What is P1? P1 is equal to 300 kilonewton. So that is 300 into 10 to the power of 3 by area of cross section. The diameter is 20. So pi into 20 square divided by 4. So on simplification, you will going to get that value as 954.93 Newton per mm square. Similarly, stress in the segment 2, which is sigma 2, will be equal to P2 by A2, which is equal to 100 kilonewton by area of cross section. It is 30 square. So that is 100 into 10 to the power of 3 divided by pi into 30 square by 4, which is equal to 141.47 Newton per mm square. So then what is the elongation of the segment 1? That is delta 11 will be equal to P1 into L1 by A1 into E. So P1 by A1, which is nothing but sigma 1 into L1 by E. So what is sigma 1? Which is substitute the value of sigma 1 as 954.93 into 100, that is the length of the segment, divided by the Young's modulus of the material is 2 into 10 to the power of 5. So on simplification, you will go to get it as 0.4775. Similarly, elongation of the segment 2, which is delta L2, will be equal to P2 into L2 by A2 into E, which is equal to sigma 2 into L2 by E, which is equal to, substitute the value of sigma 2, which we have obtained here from the calculated value, which is 141.47 into 200 divided by 2 into 10 to the power of 5, which is equal to 0.1415. So since the elongation is both the bars, both the sections has got the tensile load, therefore it will be total elongation will be equal to delta L, which is delta L1 plus delta L2, which is on substitute the value of delta L1 and delta L2 as 0.4775 plus 0.1415. So it will be equal to 0.619 mm. So this will going to be the final solution for our problem. Now we are going to take up one more problem. The problem of 24, the problem number 24. A brass bar having cross-sectional area of 300 mm square is subjected to axial forces, which is as shown in the figure. So this is the bar having the uniform cross-sectional area of 300 mm square is as shown in the figure. Find the total elongation of the bar, which is E equals 84 GPa. So here the cross-sectional area is 300 mm square, having the length of the cross-section as 500 mm in the first case and 1400 mm in the second section and 1000 mm in the third section. Having the 50 kilonewton is applied on the left hand side, here 80 kilonewton is applied to the right hand side, and here 20 kilonewton is applied to the left hand side, and 10 kilonewton is acting towards the left side on the end. So how to analyze this problem? If you are considering the section 1, the load act on the left hand side of the section. If the load is acting toward the left side, it becomes tensile, so therefore it will be positive. On the left hand side, if the load is acting toward the right side, then it becomes compressive, so it is negative. So here, similarly, on the right hand side of this section will be, if it is acting toward the right side, it is tensile, which is positive. If it is acting towards the left side, then it is negative. So if you are considering that, so there is only one force which is acting, which is 50 kilonewton toward the left side, so obviously that should be positive value. On the right hand side, you have three forces which is acting when it is 80, 20 and 10. 80 is acting towards the right side and 20 is acting towards the left side and 10 is also acting towards the left side. So on the sign convention, so you will going to get it as 80 minus 20 minus 10, 80 minus 20 minus 30. So it should be, it is 10 here, which will going to be 50 kilonewton. So in the first segment, you will going to have the tensile load of 50 kilonewton on the one side and similarly 50 kilonewton on the other side. Having the length will be 500 and the cross-sectional area is 300 mm square. Similarly, when you are considering for the second section, when you are considering this second section of 1400 mm length having 300 mm square at the cross-section, again on the left hand side, the acting toward the left side is tensile, it is positive, and acting toward the right side is compressive, it is negative. And similarly, on the right hand side of the second cross section, which will going to be acting toward the right side is positive because it is tensile, and acting toward the left side it becomes negative because it is compressive. So if you are considering these sections, you will going to get this 50, which is acting toward the left side, is positive. So here 80 is acting toward the right side, it is negative. So 50 minus 80 will going to give minus 30. And when you are taking on to the right hand side, which will be minus 20, minus 10, which will going to be minus 20 minus 10, which is equal to minus 30 kilonewton. So obviously it should be compressive in nature. So here the load in the left hand side, since it is negative, it is acting towards this right side. So it is right here. And the magnitude is 30 kilonewton. So you have got 30 kilonewton here. And here by sign convention, if it is acting toward the left side, on the right hand side it becomes compressive. So minus, so it is compressive. And the magnitude is 30. So you got 30 kilonewton. And the area of cross section is 300 mm square. And the length of this cross section is 1400 mm. So then in the final cross section, what you have, again, if you are considering that it is the section which is acting toward the left side is positive, which is because tensile. The force which is acting toward the right side is negative on the left hand side of the cross section. And similarly, the right hand side of the right end, which will going to be the load which is acting toward the right side is tensile, which is positive. The load which is acting toward the left side is negative. So here there are how many forces which is acting? So one is to the left side is 50, to the right side is 80, to the left side is 20. So by sign convention, 50 plus 20 is 70 minus 80, which is going to give you minus 10 kilonewton. On the right hand side, you will going to have only the left side direction according to the sign convention. On the right hand side, which is acting toward the left side, will be negative, so minus 10. So you are going to get it as minus 10. So since it is minus 10 on this side, minus means the convention is towards the right side, so towards the right side. And the magnitude is minus 10, so you're going to get 10. So according to the convention, it is minus, it is acting toward the left side. So on this side, it will going to be left side. And then it is the magnitude is 10 kilonewton. It is 10 kilonewton. This is 300 mm square area of cross section, and the length is 1000 mm. So the first segment is tensile, the second and third segment is compressive in nature. So for the equilibrium of the bar, so the loads acting towards the right side must be equal to the loads acting towards the left side. So that is 80 is the only the load which is acting towards the right side, and then 50 plus 820 plus 10. So 80 is equal to 80, hence the bar is in an equilibrium condition. Now what is the free body diagram which we analyzed totally? Now we will going to find out what are the elongations in the segment 1, segment 2 and segment 3. In the segment 1, which is delta L1 will be equal to P into L by P into L1 by A1 into E. So what is P1? P1 is the first segment, which is 50 kilonewton. So 50 into 10 to the power of 3. And the length of the segment is 500 divided by area of the cross section is 300 into 84 GPa is nothing but 84 into 10 to the power of 3. So on simplification, you will going to get it as 0.9921 mm. Similarly, if you are considering for the contraction of the segment 2, because it is the compressive load which is applied, P2 into L2 by A2 into E. P2 is nothing but it is 30 into 10 to the power of 3 into L2 is 1400 divided by A2 is 300 into 84 into 10 to the power of 3. So on simplification, you will going to get it as 1.6667. Similarly, contraction of the segment 3, which will delta L3 will be equal to P3 into L3 by A3 into E. So on simplification, which is 10 into 10 to the power of 3 into 1000 divided by 300 into 84 into 10 to the power of 3. So which will be equal to 10 into 10 to the power of 3 into 1000 divided by 300 into 84 into 10 to the power of 3. On simplification, you will going to get it as 0.3968 mm. So what is the total change in length of the bar? Delta L will be equal to delta L1 plus delta L2 plus delta L3. So delta L1 is, what is that? Delta L1 is tensile load, which is equal to 0.9921 minus, because it is the compressive in nature, it is minus 1.6667. And again, the contraction of the segment 3, which will going to be P3 into L3 here. it is not 310, it should be 10 into 10 to the power of 3, which is 10 kilonewton is the one which is going to be applied. So minus 0.3968. So on simplification, you will going to get the negative minus 1.0714 mm. So what is the total change in the length of the bar? The total change in the length of the bar is 1.0714. Since it is a negative sign, so the total final elongation or the contraction will going to be the final contraction. So this is how you will be able to solve this both the problem. And if you find this video is useful, kindly subscribe to my channel. Thank you.